furia, madre. Muere.
Type is a list 1. For those of you who still care whether it's a list 1 or a list 2, I don't know whether many of you even know what the difference is. So a list 1 is something where functions and variables are in the same namespace. List 2 is functions have a different namespace. That was more important back when Scheme and Common Lisp were the big guys in the Lisp room, and one of them was list 1 and one of them was list 2. Nowadays, most lists that come out are the list 1s. It's type inferred, it's borrow checked, it compiles to C, and it's made for real-time applications. Depending on your background, type inferred and borrow checked might not mean much to you. So the way to think about it is that type inferred means that it's statically typed at no extra charge, and borrow checked means no garbage collection without extra charge. Without extra charge means you don't have to do anything about it, or mostly. For type inference, you can, of course, annotate your functions if you want, but you don't have to. The goal is we figure everything out ourselves. And both of these concepts aren't new, so the type inference that we do is based on Haskells, and the borrow checking we do is based on Rust. So Haskell implements a Hindley-Milner type system, which is a very fancy word, but it's actually very straightforward and it's very powerful. And that just means you don't have to spell your types out, and Rust implements borrow checking, which means you don't have to manually manage memory, but you also don't have a GC. It just figures out the lifetimes of values, meaning where they are still used, where they're alive, and once they aren't, it inserts a destructor or it frees the memory there. Carp puts these things together, adds some list macros, adds a good CFFI, and it also simplifies both of these concepts. Partly, that is because we're a small team of enthusiasts, we don't have the time or the resources to implement all of Haskell or all of Rust, but also we try to make it as simple as possible first, try to figure out what we can leave out while still making it usable and a joy to use, and see whether we can get away with it. We probably won't, we probably have to add more stuff in the future, but for now, it's good enough. Okay, let's look at some code. So, ignore the two comment lines on the top there. Basically what you see there is the definition of a function x, f. That's kind of like, it kind of looks like Clojure if you squint. It takes 3 arguments, x, y, and z, and what it returns is a copy, that's what the add is for, of the nth element of x, so x is obviously an array then, of the product of y and z, which then must be integers. Sorry, that's the index of the element then. And if you type that into REPL, and then type f or $tf, you get back this, which is almost a type annotation as you could use it in code, which just says, this is a function that takes in a reference to an array of a, whatever a is, so any array that has this type variable, to int, and it returns an a, which makes sense because an array of a that we're trying to access, and what will be returned is, of course, of the same type, the array type. How you define types, that's how. I think most of you might know what an associative array is. It's basically a hash map implemented as a list, where you have pairs, and you look up things linearly. But what we're doing here is introducing type variables, so A and B are type variables that tell us, okay, I'm going to use 2 generic types, and in my definition of that struct, which has one member, LST, we have an array of pairs that use these 2 types, so it can be any type. So while I said the type system is like Haskell's before, actually it's closer to OCaml at the moment, but that's mostly because we haven't implemented any of the more, advanced features. Alright, so I'm going to code some, and I hope you're going to enjoy what I'm doing. What I'm going to be doing, I wrote a little library that is based on processing, or not based on processing, it is a re-implementation of processing using SDL, which we have bindings for, and it's called Anima. And what we're doing here is just we load the Anima file, we use the namespace, or the module rather, we define variables, we define them to set a function, the draw function just draws a background, and then we say sketch, which is a macro. Alright, so that's CR, this is going to compile and run, and as expected we get a window with a grayish background. Alright, so now I'm going to just add some things. The goal of this isn't that you understand what I'm doing, but more that you see the development workflow that you have. So I'm going to set the color to 200. That is, so color and background both take either 1, 3, or 4 values from 0. If 5, if 1, then it's a grayscale value. If 3, it's an RGB value. It's an RGBA value. Okay, so we're going to draw a line next, and we're going to say, okay, I want a random x between. Keep my typing, I'm very slow, but so a random value. And what's interesting here is that random between is actually an interface, so maybe it can figure out how the correct type, but in this case it won't, because there's actually the same function, more or less, defined in the integer module. So when I do this, I'm getting an error. Several matches for interface lookup symbol, random between of type int to int. That isn't super helpful, but if I run it not in my editor, I will get this error that says int random between or anima random between are the 2 things that we could choose. And for now, we're just going to say, okay, take the anima version. Try it out. Works. So what happens now is, I don't know, yeah, you can see that. Just jumping around line. So there, we render a lot of frames a second, but we don't want that, right? I'm going to fix that in a second, but first let's draw some more lines. So we just introduce a for loop, right? Oops. We introduce a for loop. We draw again. And this is what this looks like. Let's reduce the frame rate. We just do that in the setup function. Frame rate of 1 if I... Start your startup on the cart, or if you do tell me. I'm going to tell you that that's a bad idea, and you're a bad person to do that kind of stuff. But I want to hear it because it's also kind of awesome. And I guess that's all I have. So thank you, and I think I have enough time for questions.
Yes, you do. No questions. This is a difficult one. One more one. You do type checking after doing macro expansion.
That's a good one. I wanted to actually say that. I ended up saying it, did I? So the macro system typed, which that's why we can do the metaprogramming part. At macro expansion time, you still have just symbols and you have lists, and that's all fine. We don't know about anything yet. But get expanded, then the type checking happens, and we do some work to make it a bit more friendly with the error messages, because it kind of is hard to do error messages once you've expanded the macro. They're not as informative. So we link back to the old objects and all of that, and keep that in state, and you still know where you did the mistake and not where the macro expanded and blew up, and you have no idea what kind of code this is. Right.
Okay, I'm a little bit clueless about borrow checking, and it seems to me to make it very hard to make data structures or persistent data structures that share parts, like lists that share their tail or something like that. So, how does that work in Carp? And if it doesn't, who in their right mind would make a list with borrow checking?
So, it doesn't. We don't have any of the some data structures that you have. We have other structures. We have so most of our more advanced data structures, so arrays are still in the core, but for instance, just a reader macro, it's all a library inside Carp, so it's written in Carp. Same for like heaps and all kinds of other data structures. So the way I would describe, or why we do that, is basically, I think Eric said to me, Eric is the person who invented it and who works on the compiler primarily, where I work on the standard library and do some compiler fixes when I find something. Eric said to me, it's basically some of list's capability cool, but other than that, it's not really a list. It doesn't feel like a list, to me anyway.
Any more? Yeah. If you have questions, you'll join this line here. Next one. Sorry. Hi, thanks, that was a nice presentation. I'd love to but
in production, but to try out, give feedback, make it a good language, help make it a language that you would actually use. That's the thing.
So you mentioned earlier that you use modules rather than namespaces. So these are ML cell modules? You get things like functors as well?
No, so the difference in modules and namespaces is a bit, I should probably just have shown a module to exemplify things. But there's two ways to write a module. First, if you want to encapsulate functionality, of course, in the package. But also, what happens if you define a type is that it also opens a module that is named after the type, that has the type constructor in it, and getters and setters and update functions. Update functions are setters that take a function that updates the structure. But once you've opened that module, you can then extend it, which is the same syntax as if you open it for the first time. But the way this works is you have basically extensible namespace. So
Onnistaa.
if I want to extend int, float, or whatever number, double.
案内所の前。その残りの日にちを区間変更っていうのでやった方が、一回解約するよりはその方が。
Our average product is a real estate company and the app associated with that that many of you will have used. I think with a good idea people have used in Australia, there's all the adults that would be searching for property to buy and rent. And it was really written in 2010, which is why I had to block being a programmer for a few months, and I'm still blocking as Sam mentioned. And so I worked on it on and off and seen that journey. And over that journey was scaled from having a single app focused on residential property for Australia, which is obviously one that most people would see, to a whole bunch of different apps. So we have a real commercial, is our business focused on commercial property. We have our Property Night, which is focused on our customer side of our business, so the real estate agent side. So you will have seen the public facing ones. If you're a real estate agent, you can use Ignite. If you're a real estate agent, you're probably the wrong conference. And then we've also expanded into Asia in the last few years through the iProperty business. So we have apps in Malaysia, Singapore, Indonesia, and Hong Kong. We also have business in Thailand, but we don't have a mobile app there. And so the scale of what we do and the scale of the operator has changed quite a lot. And our scale journey on mobile has been different to what we have on the web. So if we look at the way REA has scaled over the years, we have this chart which looks at our growth in people, our growth in systems over time. And then this is due to moving to microservices pretty heavily on the back end and then some micro UIs as well. And so you see that as our people grow, the number of systems grow pretty quickly. It was originally projected from 2016 and it's almost exactly maintaining about 1,000 systems in production. So amazingly, the projections from a few years ago stayed pretty accurate with that. But the same approach hasn't been possible for a native apps. You can't split up your app into 100 different apps and ship them all to the store separately. That doesn't really work. Even if you could, you'd end up with a really disconnected user experience. So that's where the way thinking about the is because we built lots of separate websites. It was technically very easy to do, but you end up with a very disconnected user experience. So we'd actually rather be more integrated. And so those kinds of microservices continues to deliver lots of autonomous teams focused on certain product areas. It's been very successful, but it doesn't work quite the same way for mobile. So we've been thinking a lot in the last maybe 3 years about how do we scale our mobile development, now how do we get all of our features in there, now that's where a large part of our audience is. We now actually have about 40 mobile developers in the company, so it's not just a single small team. But I think in terms of raw headcount, that's plenty to do what we need to do, and there's other reasons why we're inefficient. It certainly feels like we don't have enough capacity to build the features and get them into the apps as fast as we would like. But when we compare that to the number of, say, specialist web developers we have, we found that we actually have more people that specialise in app development than, say, specialists in building up the web UIs and the JavaScript developers. And yet we seem to be able to build way more products for the web and build them way more effectively than we do for mobile. So that tells me that our mobile capacity problem isn't about the raw headcount, it's not about throwing more developers at it and then hire more and more specialists. It's about the ways that we work and the patterns and the architecture. That's what I want to go through. I don't see a lot online about how people are doing as well. When I asked around Melbourne, that's where our head office is, I asked around other companies in Melbourne to say, are they facing similar challenges, how are they solving them? And lots of people are facing similar challenges, not many people are very advanced in solving them. And so I've been trying to reach out to companies globally over the last 18 months or so to find companies that are in a similar situation to us, similar scale, and see if there's common